Hello, welcome, and thank you for joining me today to have this discussion, I guess, about whether modern farming is serving society. I know that this topic is controversial. In fact, most of the material in my book is controversial. That's actually why it had such a long gestation period. It took me 4 years from woe to go. I needed to be settled about what I was writing before I was prepared to actually put it out there. Gerald Tooth, a former ABC journalist and producer, describes the book as a little book that asks some big questions, and one of those questions I'm posing to us today. With respect to your questions, I'd like to handle those at the end if I may. It's about a 35-minute presentation, and unless you have a point of clarification, then we can deal with those at the end. Today I'm going to talk about modern farming, which includes our farm on the Darling Downs. Our family ran an irrigated cotton and grain farm and cattle feedlot for more than 50 years. We were the penultimate of modern farmers, highly respected and high achievers, open, innovative and with a keen eye on the ball. And precision was what we aimed for. Just the crop we were planting, no other interference such as trees, animals or weeds. Part of that precision was neatness, and part of it was preservation of ground moisture, which we thought demanded a very strict regime of weed control. In the plant bed prior to planting, on the crop just before harvesting for desiccation of the green matter, in the crop stubble after harvesting, and on the verges between the growing season. And there's nothing unusual about that. If you ask, any self-respecting farmer on the Darling Downs will tell you that neatness and weed control was part of the package that you judge yourself on. The other was yield, of course. That was the one that was discussed socially and at grower meetings. Rainfall and yield. Highest yield didn't necessarily mean highest profit, but it was a recognised benchmark. Anyone in the audience who's been a farmer or who knows a farmer, you'll also know that weed control in modern farming means glyphosate or Roundup, and yield means artificial fertilisers, especially nitrogen. Then there was the insect control, firstly coating the seeds prior to planting to keep the ants at bay, then spraying the crops during the growing season for whatever pest liked that crop, as many times as was necessary or economical, and still within the legislated withholding periods before harvest. Sometimes by air, more often mixed ourselves and sprayed from our own ground equipment, and usually in the cool of the night. Because this was when the wind was down, insects were busiest and there was no heat to affect the chemicals. In addition, we had a cattle feedlot. It sustained us when the grain prices were down because cheap grain meant more profit in the cattle. Bill's family were pioneers in Australia's feedlot industry, with one being one of the very first and one of the longest operating feedlots in Australia. We fattened for 90 days for local trade, and we fattened for 180 days for export. Before my time, they were the first family to send chilled feedlot beef to Japan, and they constantly innovated with feedlot rations, early uses of shade cloth, the construction of one of the early grain ethanol plants experimenting with sorghum to convert it to ethanol, whereas in the United States they're mainly converting corn. Of course, not all the trials were successful, but trialling was part of the makeup of the Bridgford family, along with the bottom line. We did it very well, on all accounts, really. Our farm and feedlot were both a business success. I was closely involved in all this farming activity, not so much in the paddock or the shed, but very much in the office at different levels over the years. I was also out on the hustings promoting the cleverness of modern agriculture. In fact, I achieved my ARLP scholarship for my leadership and contribution to adult education in the grain industry. I distinctly recall some arcane bureaucrat in the Queensland Government questioning me on why we would need the likes of the Dalby Agricultural College, of which I was the Deputy Chairman, wondering why we couldn't just have traineeships. I looked him in the eye and said, "Our equipment costs hundreds of thousands of dollars. We need educated people to be running our farms." He was silent after that. I tell you all of this to set the scene for the real reason that I'm here. I also tell it to you to show that I think we've got a fair bit of street cred. We were fair dinkum modern farmers in every sense. Historically too, almost every line in our family tree are farmers or graziers. Maybe a point of difference is that both Bill and I attended university in non-ag related studies before we became farmers ourselves. Bill's a trained lawyer and I'm trained in psychology with an MBA. We spent almost 20 years on our farm, that's Bill and me. In 2002 we left for a year's break and we never returned. We leased it and then eventually sold it in 2010. I've stiffened my views a fair bit since then. I didn't like a lot of what we were doing, although I participated in the decisions. I now know what was gnawing away at me. Today, I think that modern farming is dysfunctional. It's dysfunctional for the plants, it's dysfunctional for the animals, it's dysfunctional for the soil, the farmers and the consumers. I also think that modern farmers have become caught up in this dysfunctional cycle by default. Some already know that it's a one-way street, but have no idea how to escape. Others are blindly travelling along. A few, though, are making alternative choices. Adversity brings about creativity that may not otherwise surface. And I think it's this dysfunctionality that brings into question modern farming's relationship with the wider society. That's what I want to really focus on today, modern farming's relationship with society. My goal in the next half hour is to encourage you to at least ask that question in your sphere of influence. I think that modern farming's very integrity is under threat, and I don't say that lightly. I don't want to leave you with an impression that I'm critical of the farming community. I know firsthand the immense pressures modern farmers are facing. I also know firsthand that it cannot go on. It must change course. It has to. The question that I ask is, will society emotionally and financially support a food system that is dysfunctional? Now to the nitty-gritty. Why do I say that modern farming is dysfunctional? I'll be discussing two specific pathways of nature at the centre of this explanation. Pathways which, when allowed to function, form key roles in human health. Pathways which can be interrupted very, very easily. And when they are interrupted, cause a cascade of effects that could not have been imagined without witnessing them. One has led us to the other. It's a fascinating house of cards, and I'll show you that at the end. So there's two pathways I'll be discussing. The first pathway is the carbon-mineral exchange that delivers to our plates meats, fruits and vegetables laden with vitamins and minerals. Its interruption not only leaves us with empty food, it also leaves us with empty soil. The second is the Shikimate pathway, a biological phenomenon that converts amino acids into hormones essential to our physical and emotional well-being. Its interruption leaves us without critical levels of hormones that control our insulin levels, our sleep patterns, our levels of happiness and appetite, our movements and our memory. Remember, I highlighted at the beginning of this presentation, the farmer's need for yield equals nitrogen, and the farmer's need for weed control equals glyphosate. Professor Albert Frank discovered in 1885 the symbiotic relationship between fungi and the roots of plants, especially mycorrhizal fungi. Dr. Christine Jones, an Australian soil ecologist, brought this to my attention in 2010, and it has captivated me ever since. Through photosynthesis, as you can see on this diagram, CO2 is absorbed out of the atmosphere into the plant. The oxygen, the O2, returns to the atmosphere, and the C, the carbon, stays in the plant and transports down into the soil. The carbon reaches the soil through the roots of the plant. Then it becomes food for the critters that live in the soil. Mycorrhizal fungi, this large mass that you can see, are attached to the roots, and they are what deliver the carbon to the critters. In exchange for the carbon, the mycorrhizal fungi then draw minerals out of the soil. Essentially, the presence of carbon and mycorrhizal fungi makes the minerals in the soil available to the plant. For humans, that's a good deal, because we then eat those plants laden with minerals from the soil. For the soil, it's also a good deal. When the carbon travels down into the soil and feeds the critters, they die and eventually turn into humus. It's humus that makes healthy soil, and humus that builds new soil. This can only occur with the presence of carbon. The process is called carbon sequestration, sequestering carbon from the atmosphere into the soil. It's brilliant. Each feeds off the other, and an ideal exchange of nature takes place, building both the plant health and the soil health, as well as the soil itself. When we eat these plants, we benefit from it, or when we eat the animals that graze on these plants, we benefit from that as well. Enter now artificial fertiliser. Since the 1950s, we've been using artificial fertiliser in increased quantities. I explain in the book the political and economic reasons for that, but for now I'm going to concentrate on the health impacts to the soil and to humans. We all know that when we fertilise our plants, they grow bigger and faster. That's why we do it, to increase our yield. What we lose in the process is two things. We lose the health benefits of the plant, and we lose the health benefits of the soil. Here's how. When the plant's fed an artificial fertiliser, it receives all that it needs to grow. This means that it no longer needs to draw its nutrients from the soil. As a result, the plant does not send the carbon down through its roots into the soil, because it was only doing that to obtain the nutrients that it needed to grow. But that's not necessary anymore. When there's no carbon exchange, then the nutrients that are in the soil become bound up in the soil, not absorbed into the plant. And you can see in this diagram, when there's no mycorrhizal fungi actually using those nutrients, then they become dormant in the soil and they disappear from being attached to the roots. The second thing that happens is the soil is no longer replenished and rebuilt. Its only available pathway is decay, which happens anyway. Soil, like our bones, needs to continue to replenish to form the structure of the earth and the structure of the human body. When there's no replenishment, soil loss is inevitable, and decline in soil cell health is inevitable as well. So two things have happened here with the simple application of some artificial fertiliser. The plant that we eat start to lack nutrition. In addition, the soil that grows those plants is no longer replenished, but continues to decay. As less and less of the minerals in the soil become available to the plant, more and more fertiliser is ultimately required to achieve the original yields from the addition of the artificial fertiliser. Time and repeated process magnifies the need for fertiliser to obtain the yield and the decline in the nutritional qualities of the food. Time and repeated process also causes deterioration of the soil, so that eventually our topsoil disappears and we start farming on our subsoil. So here's a few graphs to tell the story of our increased use of fertiliser over the years, the depletion in the minerals in fruit and vegetables from 1940 to 1991, and a graph showing the decline in soil nitrogen and wheat grain protein with increased cultivation over the years that parallels with a graph that shows a similar decline in the level of grain production that's capable of being achieved per tonne of fertiliser applied. They're actually very telling graphs. And there's another graph showing world population as the title, which has got fertiliser in the purple dots and yield in the average cereal yield in the green dots, and you can see the increased use of fertiliser for a more moderate increase in yield. The second pathway that I'm going to discuss is the Shikimate pathway. The Shikimate pathway is a form of biosynthesis. which is the process that happens in natural systems, building up larger, more complex molecules from simple precursors. It's an essential pathway in plants for the synthesis of 3 amino acids. And it's an essential pathway for our gut bacteria for the synthesis of those same 3 amino acids. Our gut bacteria use the Shikimadi pathway to convert those amino acids into essential hormones for our well-being. They produce serotonin, which regulates our appetite and our moods, melatonin, which regulates our sleep patterns and our circadian rhythms, dopamine, which plays a major role in our movement and memory, and more. Our gut bacteria supply us with nutrients and protect us from toxins. Enter now Roundup and its active ingredient, glyphosate. Remember I said at the beginning that for modern farming there are 2 essential ingredients: fertiliser, mainly nitrogen, for yield, and chemicals, mainly glyphosate, for weed control. Glyphosate, which is the active ingredient in Roundup, kills weeds by interfering with the Shikimadi pathway in the plant. We obviously don't eat those weeds that it's sprayed on, and human cells do not have the Shikimadi pathway, so you might wonder how it could impact human health. It seems that it can, and here's the explanation. While our cells do not have the Shikimadi pathway, the microbes that live in our digestive tract do have that pathway, as I explained, our gut bacteria, and they outnumber our cells by a factor of 10 to 1. Consumption of plants sprayed with glyphosate or direct absorption of glyphosate from the soil will interrupt the Shikimadi pathway of our gut, thus suppressing the production of these 3 essential amino acids, which are used to produce these wide-ranging hormones. Dr. Stephanie Seneff, who has done a far-reaching study in the impact of glyphosate, says that there's also an intricate connection between the gut and the brain, such that an unhealthy digestive system translates into pathologies in the brain. Time is the storyteller in this one. Perhaps impacts were not known initially, but it's fairly widespread now that glyphosate does impact on human health, is probably carcinogenic, and potentially linked to a wide range of chronic illnesses in a significant way. Dr. Stephanie Seneff has also said glyphosate causes an overgrowth of pathogenic bacteria in the gut, interferes with the supply of critical neurotransmitters to the brain and the nervous system, and is an established endocrine disruptor. Modern epidemics of poor gut function include gluten intolerance, Crohn's disease, and leaky gut. Modern epidemics of impaired brain function include autism, Alzheimer's, and depression. And I've already shown you how the impact of the endocrine disruptors with respect to our hormones. In modern farming, glyphosate is used to kill weeds prior to planting, ripen and desiccate a crop before harvesting, to kill weeds in the crop when growing BT cotton or GM canola, which are both Roundup ready. Also used in the USA in very high quantities on all GM crops of cotton, corn, canola and soy, because these crops are Roundup ready so they can withstand high levels of in-crop weed control with glyphosate. Glyphosate becomes systemic in the plant. It's absorbed, it cannot be washed off. It's a chelator, so its presence in your body and in the soil immobilises nutrients so that they are not physiologically available for your body. It's also patented as an antibiotic, thus demonstrating that it can kill vitally important bacteria in the soil and in the gut. It's a cumulative chronic toxin. It doesn't actually leave your body. It's been found in breast milk and water supplies in parts of the US. I've got here on the screen 3 graphs that show a correlation between particular diseases and the increase in the use of glyphosate. The glyphosate is the red line and the different diseases are the bar graphs. Top left is thyroid cancer, top right is deaths from senile dementia, and the bottom one is autism. These are US statistics where they do have an exceptionally high use of glyphosate due to the very high levels of growing GM corn and soy and canola. nonetheless, they are statistics that I think really paint a picture that really requires us to think carefully about the role that it could be playing in our health. I said earlier that I would show you how one has led us down the path to the other. In the 1950s, we started to use nitrogen on corn crops in the US and achieved much higher yields. This led to widespread uptake of large-scale monoculture, causing the separation of plants and animals from the same landscape. Next was the development of the animal feedlot industry, where large-scale corn production supported the output of consistently graded grain-fed cattle and chickens, suiting the fast food market that wanted to access the same quality product everywhere. Nature, though, wasn't so sure about this artificial separation of plants and animals from the same landscape. With large-scale monoculture and large-scale intensive animal production, weeds and disease started to appear where previously nature had built resilience and resistance. Antibiotics became the saviour to the intensive animal industry, and from the 1970s, Roundup joined the ranks as being heralded as the saviour of the monoculture plant industry. We now have superweeds in the farming industry, nothing can kill them, superbugs in human health, nothing can kill them, as well as a list of chronic diseases as long as your arm. Coincidence, you may say? Maybe or maybe not. These are the questions that the buyers of food are starting to ask. Do you ask these questions in your family? If not, do you think you should? I think that these are the questions that our agriculture industries need to also start asking. Food buyers are making choices in many instances to buy meat, fruit and vegetables that are grown without chemicals, and to buy meat that is grass-fed rather than grain-fed. I wrote a blog recently after a trip to the US where I was quite fascinated. I explained I was quite fascinated by the level of uptake now of food that really is shifting towards chemical-free and much reduced chemicals. So what could be the reason for that? What's happened to our food industry since the 1940s and 50s I think is absolutely mind-blowing. I started to absorb this information over a period of 5 or 6 years after we'd left the farm, and I really started to question things. The more I researched and started to question the way we used to farm, I started to realise I was drawing to a point where I was actually challenging what we had stood for. As I said before, we were the penultimate modern industrial farmers and feedlotters. That was a tough one for me. To bring it all together and make it make sense to me, I took the step to start writing it all down, and the book is what grew from there. Over time, I have come to realise that there's quite a bit that we could understand better. And if we understood it better, then we as farmers might actually think differently about the way we grow our food, and as consumers start to make different choices. Because the reality is we do have a choice. We've actually got a choice as human beings to farm the way we do and a choice to eat the foods that we do. The more we know about that, the better choices we can make. I think it's time for modern farming to face this message. The current system cannot continue, not only because of the health of the plants, animals and soil, but I think humans will drive change through our own need for survival and the gradual realisation that the source of our food is also the source of our own health. We used to know that, it got lost for a while, and I think it's back again. What role does farming really play in that story? I could go on, but I actually don't want to. I don't want to create doom and gloom. I want us to start asking questions. Here's a summary. Empty food with loss of minerals and nutrients. Empty soil with loss of minerals and nutrients. Empty soil with loss of carbon to create new soil. Loss of gut bacteria to generate our critical hormones that govern our levels of health and sociability. That's all pretty damning, isn't it? How have we come to this extraordinary situation? What's led us down this path of dependence on artificial fertilisers and chemicals to produce food that's virtually manufactured rather than grown and potentially slowly killing us?